Good afternoon. Mark Thompson here with Realtime with IPC. I'm here this afternoon with Shane Stewart and Michael Kwok. Shane is with Perfect Point and Michael is with Jinzo.
Yes.
Gentlemen, I understand you have a new product that you brought to the show and some information about drilling and drill points. Talk to us about those new tools.
Definitely. Well, there hasn't been a lot of changes in the drilling world in PCB for quite some time. In the early 90s, we came out with the undercut style drill, which seemed to solve a lot of our problems at the time of hole wall quality. About 3 or 4 years ago, the single flute geometry was developed. And that's what we were able to do with that is take the two flutes that traditionally helix up a tool and migrate those into one single flute, which has a much larger chip space. By doing that, it allowed us to thicken the web or the core of the tool for added rigidity.
I love it.
Yeah. From there, and those tools have been in the market now for about 3 or 4 years. There's many suppliers have that line. But we've also noticed in the past few years a need for the next generation of the single flute. Our builds are getting thicker, higher layer counts, our coppers are getting thicker, and there's a much more stringent requirement for accuracy.
And the hole sizes are dramatically dropping.
Getting way smaller, yes. Like I was telling you earlier, we sell in volume now down to 3 mil.
Outstanding.
So we've taken the traditional single flute geometry and gone back to the drawing board and enhanced some of the features. Instead of having a single helix going up the tool, we'll have several segments of helix now. As well as the core or the web of the tool, we use a variable web now. So what we've actually done is tested out the tool, established a parameter set that we can generate a certain chip size, and that chip size becomes conducive with the helix with the flute of the tool, so we can more effectively evacuate the debris.
In conjunction with that, have there been changes in the actual formulation of the metal that's being used for making these particular tools?
Definitely, yes. We've gone into nano grain carbide now.
I see.
Back 10 or 15 years ago, our cobalt content was the same, but the particles were much larger. Now we're into nanoparticles, so this allows a little bit more flexibility of the tool to prevent breakage.
And longevity?
And longevity, yes. With the smaller cobalt particles, when they chip away, which is wear, you're breaking away smaller particles, which increases the tool's life.
Sure.
Yes.
Outstanding. What would be the direct benefits to PCB manufacturers such as ourselves with the use of these tools?
Well, again, as mentioned, we were able to thicken the core of the tool or the web, which provides the rigidity. So, 10 or 15 years ago, accuracy was part of the equation, but our pads were also this large.
Exactly.
Now we're getting into, we get pads that are diameter +3 in some occurrences.
Or less.
Or less. So we must focus on the accuracy of the tool. So in increasing the web thickness of the tool, it becomes much more rigid and does not skate or dance during the drilling process. At the same time, with the two flutes migrating into a single flute with that larger debris evacuation, we generate less heat.
Okay.
And if we generate less heat, then our drill bit will last longer and give us a much better hole wall quality.
So you don't need a specific entry or back material?
No, and that's what we've done with the next geometry of drills. We've been able to eliminate some of the drilling band-aids or aids that I call them. A lot of people are peck drilling, pilot drilling, using accuracy enhancing entries and lubricated backups. With the testing that we've done on the next generation, we've been able to eliminate all of these and just drill, we call it a pure process, and be able to just drill a pure hole.
Outstanding.
But at the same time, with the enhanced flute volume I was mentioning, we're able to run our tools at a much quicker in-feed rate. So it's equated to about 10 minutes of cycle time savings per 10,000 holes.
Outstanding.
Yeah.
Michael, tell us a little bit about Jinzo.
Yes, I'm Michael Kwok from Jinzo, the manufacturer of PCB drills, and Perfect Point is our partner in North America.
Okay.
And I'm very happy to be here, IPC Show 2017, and I want to thank all our customers in North America.
Is this your first IPC show?
Oh, no.
Many years.
Many years.
I love it. All right.
Yeah.
What about any additional new products that you might have brought to the show that you'd like to share with the audience?
See, there's something I'd like to mention. We've worked with a partner company of ours called Advanced Copper Foil to develop a peelable layer on the bottom of a circuit board. So with modern constructions, they're getting thicker. Sometimes we get an unbalanced build that causes some natural warpage. And at the same time, we're doing a lot more of the component size, or sorry, press fit connector holes
Exactly.
that do not allow for any burring.
No, plus or minus 2000s. That's a tough trick.
And it very much is. So we've developed a system where during lamination, we can laminate on a 2-ounce carrier to the bottom of a panel, and then you'll keep it on through the drilling cycle, and then post-drilling, you just peel away that entire layer, revealing the pristine outer layer surface.
Eliminates any of the burring from the backside.
Definitely, yes.
Based on
yes.
that mismatch in lamination and potential mismatch in dielectrics or copper weights.
Yes.
That's fantastic. Oh, I bet you're very excited about that product.
Very excited. Like I said, we're just in our beta site right now, or beta trials right now, and we expect to release within the second quarter of this year.
I love it. Well, I'm anticipating that, and I'd like to get some literature from you guys myself for our shop.
Definitely.
Appreciate your time. I have been here this afternoon with Shane Stewart and Michael Kwok. Michael from Jinsao and Shane from Perfect Point. Thank you, gentlemen. Appreciate it.